When we talk about Mendel and the origins of genetics, people think Mendel is this dusty old monk working in obscurity in a monastery. And I tell the story of Mendel and how he really got there. Because science, you can drain it of the life of the people who do it, but science is a social activity. Science is curious people wanting to find out things. And you want to know, why did they want to know? I loved math all through high school. I loved math through college. I went and got my PhD in math, but I always knew in my heart that I didn't want to do pure mathematics as a career. Because as wonderful and as beautiful as mathematics is, you mostly do it inside your own head. I liked the team spirit that came from the math team. I liked the social aspects of the world. And so while I was finishing up my PhD, I cast about to try to figure out what somebody who had a love of math and mathematical background could do that was kind of more in the world, more useful in the world. And it took a number of years of casting about to figure out, what that would be. Being, hopelessly naive as one is in one's early 20s, I decided, I'd learn about the brain. So I began dropping in on random classes around Harvard on the brain, learning things, and one thing led to another, and I realized to learn about the brain, I'd have to learn about cell biology. To learn about cell biology, I'd have to learn about molecular biology. To learn about molecular biology, I'd have to learn about genetics. And that's how it happened. It was an utter accident. Started doing fly genetics, and then some worm genetics. And then one day I met a guy called David Botstein. And he came from the Bronx, I came from Brooklyn, and we started arguing with each other immediately about this. We grabbed some chalk, started working on the board, and then we got together the next day and the next day. And within about a week, I was just hooked on these ideas of human genetics that grew within a year or two into the Human Genome Project. For me, that's been the exhilarating part, is the community aspect of taking on genomic medicine. Somebody brings a perspective. What causes a particular type of cancer? They're a cancer physician. They really know about this type of cancer. Somebody else, though, brings the perspective of saying, if you can give me 100 patients with that cancer and 100 patients who have a different cancer, I know how I could analyze those data. And somebody else says, I know I get those data very inexpensively. And a set of ideas come together, and it's sort of teams that form and reform and people helping each other. I gotta say, it's the most exhilarating thing I've ever been part of, to watch the communities of genomicists come together to tackle problem after problem after problem, look at the answers, see what we learn about the world, plan out the next steps, and it attracts extraordinary young people. It's all driven by young scientists coming in who have just outrageous ambitions about what might be possible. And the things that sound utterly crazy today, if you work together, turn out to be feasible 5 years from now, and then child's play 10 years from now. We used to have these boundaries of, it was the chemistry department in the chemistry building, and the biology department in the biology building, and the math department, and the computer science department. The young scientists today, the young students coming in, they have no respect for these boundaries, and they shouldn't. They just munge it together. It's a mixtape of all these sort of different things, and that is the right way to be. These separations that we had before, now, as each of these disciplines has grown more and more and more powerful, people are now exploring the fusion cuisine that comes out across all these different disciplines. There has never been a more exciting time to be a scientist. As a scientist, when you gather information, you do that as a pure scientist. But then as a citizen, as a parent, as just a person in the world, you have an obligation to then ask, how's that being used in the world? And so it means that one's responsibilities don't just stop at the boundary of the lab. When you go home, you're still thinking about what's this impact going to be? How is it that medical advances are going to be equitably distributed across society, not just available to people who have resources, but available broadly? How are you going to be sure that we work on problems that matter in the developing world as well as in the developed world? These are the sort of questions scientists should be thinking. Scientists are part of the world. They're in the world. Yeah, a lot of times in my life when I've just been casting about, trying to figure out what's the next step, what's bothering me, where to go. In a way, it's not so different than working on a math problem, where if you try to take it on head on, you usually can't make progress. But when you take on a challenge like, what do I want to go do now, or what's the field got to do right now, or what's the big issue in cancer, whatever, you keep struggling with it, and eventually the structure of the problem becomes clear, and then the path through it becomes clear. But all of those moments of insight come from long periods of casting about and seeing all the pieces. You just have to be patient enough to wait until all the pieces really fall together. You got to be stubborn.